Okay, we are looking at solving two-step equations. These questions come from lesson 2 in your math book and can be found on page 122 and 123. What we're going to do today is just review once again a two-step equation when we have a variable and how to isolate that variable. Looking at letter A, we're first looking at 3x plus 2 is equal to 20. How can we isolate and solve for x? We know in past lessons we talked about starting by removing that constant from the expression where you can find the variable. So here we can see x, and so we have this constant of plus 2. And what we're going to do is we're going to go ahead and we are going to subtract 2 from the left side of the equation, and therefore we need to subtract 2 from the right as well, leaving us with 3x is equal to 18. At this point, we know the second step in solving a two-step equation is to remove the coefficient from the variable, and so we have 3 being multiplied by x, so we need to divide 3 on both sides. 3 divides 3, leaving us with 1, or x, and 18 divided by 3 leaves us with 6. Of course, we can go back and we want to double check our work. 3 times 6 plus 2. 3 times 6 is 18. 18 plus 2 does give us 20. So once again, as that reminder, we are circling our answers when we're doing work, and we're checking it to show that we have the right solution. In B, we can do the same thing. Now in this case, we see that we have a 5 as the constant, so we're going to subtract 5 from both sides. 5 minus 5 leaves 0, and 2n is the only term on the left-hand side of the equation. And on the right-hand side, we have negative 1 minus 5, or I might see negative 1 and negative 5. When I add them together, I get negative 6. My coefficient is 2 in the term, so I'm going to divide by 2 on both sides. 2 divided by 2, 1, leaving me with n, and negative 6 divided by 2 leaves me with negative 3. Again, I'm going to check to make sure that my answer works. 5 plus 2 times negative 3, does that give me negative 1? Well, 5 plus 2 times negative 3 is negative 6, and when I add those two constants together, I get negative 1. Let's move on to these. Here we see negative 1 on the left-hand side is equal to half a plus 9. My constant is where I'm going to start. So I see the 9. Again, that 9 is standing alone. It is a term by itself. So I'm going to subtract it from both sides of the equation. Negative 1 plus negative 9 does give me negative 10, and that is equal to half a. When I have a fraction in a term with a variable, I know I can multiply that fraction by its reciprocal. Any fraction times its reciprocal does give me 1. So I have a on the right. If I multiply by 2 on one side, I must do the same on the other side. 2 times negative 10 is negative 20. Let's check to see if we're right. Negative 1 is equal to half of negative 20 plus 9. Well, half of negative 20 is negative 10. And negative 10 plus 9 does give me negative 1 for the sum. Looking at D, my constant I'm going to identify is the negative 5. So I'm going to add 5 to both sides, leaving me with 2/5 r on the left, and it's equal to 12 on the right side of the equation. Times 5 over 2, the reciprocal, I can do 5 over 2 being multiplied by 12 on the right-hand side. 5 halves times 2/5. When I reduce and I factor out, I am left with r. Now I know when I'm multiplying a fraction times a whole number, 12 can be written as 12 over 1. times 5 halves. 12 and 2 can both factor a 2 out, leaving me with a 1 and a 6. 6 times 5 leaves me with 30, so r is equal to 30. Let's check our work. 2/5 times 30 minus 5, does that give me 7? Well, 2/5 of 30, 5 and 30 can both factor a 5 out, leaving me with a 1 and a 6. 2 times 6 is 12. 12 minus 5 does equal 7. Again, as a reminder, I am circling these answers. Now here I should have written a equals negative 20. I'm checking it. I have my r as 30. See how nice it directs my eye to looking for that right answer. And so I know that you have done your job of checking yourself. Let's look at these last three. In letter E, we are starting by that subtraction of 10 on both sides. It leaves me with negative 2/3 p. Remember that negative sign is there. We don't want to forget it when we remove the constant 10 from that left-hand side of the equation. 52 minus 10 will leave me with 42. I have my fraction negative 2/3, so I'm going to multiply it by the reciprocal. I'm going to bring that negative with me, so I have my 3 halves. I'm going to multiply by the negative 3 halves on both sides. Everything factors out, leaving me with 1p is equal to I've got to do the product of 42 times 3 negative halves. 2 and 42, I can divide both of those numbers by 2, leaving me with a negative 1 in that denominator, and there are 21 2s in 42. 21 times 3 gets me 63. Again, I've got the negative, so I've got to keep that negative over here in my final answer. P equals negative 63. Let's check that work. 10 minus 2/3 times negative 63. I'm going to make it a fraction over 1. Does that give me 52? When I look at these fractions that I'm multiplying, I see that I can divide 3 by 3 is 1. How many 3's are in 63? There are 21, and that is still negative, so I have to keep that there. Now, if you look, I've got this negative here. So now I have two negatives that I'm multiplying together. Negative 2 times negative 21 gives me 42. And that becomes positive because it's negative times negative. And 10 plus 42 does equal 52. Again, you can see with all the work the importance of circling that correct answer. Okay, now these last few are really close together, so I'm going to go ahead and just erase my work so I have room. All right, and let me bring this up a little bit here. All right, here we go. I'm looking at F. Again, whoops, where'd it go? Oh, that was fun. Okay, there. We're going to subtract 2 on both sides. Negative 19 minus 2, negative 21 is equal to negative 3x. Let me just erase this little mark here. Okay. So I removed my constant from both sides. Now I'm going to divide that coefficient, negative 3. Negative 3 divided by negative 3 is 1, so I have my x. Negative 21 divided by negative 3 does give me a positive 7. Now, it's always good in final answer form, put that variable on the left side, and x is equal to 7. I'm going to check over here. Negative 3 times 7 plus 2. Negative 21 plus 2 does give me negative 19. So I am correct. Again, so helpful. Circle your answer. Check. One more problem to go. Okay, we can do this. We're looking here. Identify that constant. The constant's minus 2 or negative 2. So we're going to add 2 to both sides. N divided by negative 3 is equal to negative 16. I'm going to multiply because here I've got my division. So I'm going to multiply by negative 3 on both sides. Negative 3 divides by negative 3, leaving me with n. And then I have my negative 16 times my 3. Now, I always like to do a little mental math reminder. So if I have negative 16 times negative 3, how many of you think, okay, negative 16 is negative 10, right, and negative 6. So when I multiply negative 10 times 3, I get 30, and 3 times 6 is 18. So I can just add those together to get the 48. And just, again, how do you decompose number? How do you think about number is really helpful when you're thinking about mental math. So back to the bigger problem, negative 16 times negative 3 is equal to 48. And we can check our work. 48 divided by negative 3, yeah, negative 16, minus 2 is negative 18. So we've checked our work. We see that we're right. We are circling our answer when we're checking it as being correct. Okay, so we have reviewed again our two-step solution for equations. When we have a constant, we're going to add and subtract first, and then we're going to take that coefficient that is next to the variable, and we're going to do the inverse operation, multiplication and or division, depending on how that coefficient is with the term. Okay, now your turn.